Gets na? We are given the problem. Problem A, cosecant squared x minus cos squared x times cosecant squared x is equals to 1. We are tasked to prove this. So what we're gonna do first is factor out the cosecant squared, since the kanang the left kanang expression has a common term, so that's why we're gonna factor it. So it's gonna be like this: cosecant squared x times 1 minus cos x, the only one remaining. The next we're gonna do is we can identify now that 1 over cos squared x is equal to sine squared x, since it is on the Pythagorean identity that cos squared x plus sine squared x is equals to 1. So if we transpose the cos squared x to the right side, we can have the remaining sine squared at the left. So that's it. Sine squared x is equals to 1 minus cos squared x. So we're gonna substitute this with this. So cosecant squared x times sine squared x is equals to 1. We're not finished yet. We can also identify that cosecant squared x has a reciprocal identity, and we know that sine x has a reciprocal identity of like this: 1 over cosecant x. So if sine squared x is equals to cosecant squared x, that should be equal. However, we know that the cosecant is still at the bottom. We're gonna make it to the top, because it's a reciprocal. It's just equals to like this: secant squared x is equals to 1 sine squared x. So as you can see, here is equal. So we're gonna substitute this value in this function. 1 over sine squared x times sine squared x is equals to 1. To further simplify, we can cancel this, and now what we are left with is 1 is equals to 1. So here, in this equation, in this problem, we will use the Pythagorean theorem, which is sine squared x plus cosine squared x is equals to 1. So here we will minus this side of negative sine squared x, and in the right side negative sine squared x, and we will cancel out this, and we will left with cos squared x equals 1 minus sine squared x. And after this, we will substitute this in this equation. So we will have 1 minus 2 sine squared x equals 2 times negative 1 negative 1 minus sine squared x minus 1. And after this, we will distribute this. It will be 1 minus 2 sine squared x equals 2 times 1 is 2, and 2 times this equals negative 2 sine squared x minus 1. And after this, we will simplify this equation. 1 minus 2 sine squared x equals this. We will subtract 1 minus 2 sine squared x. And after that, we will look at the both sides if they have the same, if they are the same in both sides. Yeah. Since both sides are the same, this equation is solved, and that is it. Okay, now we're going to prove problem C. As you can see, it's very difficult, I think, to solve this or to prove this. But using the identities that we have learned, we can solve this. So let's identify first. So tan x is, we know that tan x is equals to sine x over cos x, and that is based on the ratio identities. So let's try to substitute this in here. So this expression will become sine x plus tan, no, not tan. It will now become sine x over cos x all over 1 plus cos x is equals to tan. Simplify the numerator further. So the butterfly method, cos x sine x plus sine x over cos x all over 1 plus cos x is equals to tan x. Now that we have this, let's simplify this further, the numerator. The numerator of the numerator, we can factor out the sine squared, since sine squared is common in both terms. So sine x cos x plus 1 divided by cos x all over 1 plus cos x is equals to tan x. To further simplify, let's multiply let's remain change in the flip method. So sine remain x cos x plus 1 over cos. Let's remain the numerator, change the operation, and then flip the denominator. So 1 over 1 plus cos x. Now, as we can see, we can now cancel out the numerator of the first term and the denominator of this. So let's cancel out. Cancel, cancel, and this will equals to tan x. Since we now only have sin x over cos x times 1, sin x over cos x is equals to tan x, as we can see here. So tan x is equals to tan x. Therefore, this expression is equals to this expression. Now we have successfully proved that this equation is equals to this equation. So that's it for problem C. Now we're gonna solve or prove for this equation whether this is true. Now we're gonna prove. First, we're gonna substitute this into simpler terms. So cosecant x is equals to 1 over sine x by the reciprocal property, and cotangent x is equals to cos x over sine x by the ratio identity. Now, these values we're gonna substitute in here. So this 1 over sine x plus cot, which is cos x over sine x squared. After that, let's combine this since it has the same denominator. So 1 plus cos x over sine squared x. No, not squared. To simplify this further, it would become like this. One plus cos x squared over sine squared x. Now, I think this is the simplest form of the right side. So now let's try to make this equals to this. Let's go over here. So 1 cos x over 1 minus cos x. Let's multiply by the conjugate of the denominator. So cos x 1 plus cos x will equal to, so 1 plus cos x squared over this, which is equals to 1 and I think negative cos squared x. So that's it. And after that, we now have this 1 plus cos x squared over 1 minus cos. And we know that with the Pythagorean identity, which is cos x squared, cos squared x plus sine squared x is equals to 1. It is equals to sine x is equals to 1 minus cos squared x. Since we will substitute this, since this is equals to this. So 1 plus cos x squared over sine squared x. Let's see what we have solved first here. let's equate this with this. This is equal. So here 1 plus cos x squared over sine squared x is equals to this. This is 1 plus cos x squared over sine. And as you can see, the two expressions on either sides are equal. So that makes our solution correct. And the one is equal. So true.
So now we're gonna prove this equation, which is a sine x over 1 plus cos x and it is equal to 1 minus cos x over sine x. So first we have to remove the fraction. So what we're gonna do here is we're gonna multiply both sides by 1 plus cos x. So 1 plus cos x times sine x over 1 plus cos x. We're gonna cancel 1 plus cos x and this one. So we're only gonna have sine x left over. On the other side, we're just gonna copy it. So 1 minus cos x over sine x times 1 plus cos x. And now that we have removed the fraction on the left side, we're gonna work on the fraction on the right side na. So we're just gonna copy sine x and we're going to multiply this fraction with sine x. So what we're gonna do here is that if we're gonna multiply this side by sine x, we're also gonna multiply this side by sine x. So we're gonna put sine x here, and meanwhile here we're also gonna put sine x times 1 minus cos x over sine x times 1 plus cos x. So if we multiply sine x by this fraction, we're just gonna cancel both of this. So we're just gonna be left with 1 minus cos x times 1 plus cos x. And meanwhile here we're also gonna have sine x times sine x. And now we're gonna multiply this side and also this side. So we we will have the product of sine squared x on the left side, and on the right side we're gonna have the product of 1 minus cos squared x. We can see that this equation can be manipulated into Pythagorean theorem. So what we're gonna do here is to add both sides with positive cos squared x. So let's add both sides. So plus cos squared x, and well right here sine squared x plus cos squared x 1. So now we have the Pythagorean identity, but we can just move on and just to prove this dion. As we all know that this expression is equal to sine squared x. So this is the final answer.